Good morning. It is April 23rd. This is the fourth day, the third lesson for modeling volume, where we're finding cost slash mass slash weight by calculating volume and using unit analysis. We talked about the steps the other day. In fact, let me pause this and just pull up those steps again. Here are your steps. Your first step, you want to make sure your units are good. Your units need to match. And needs to match what they want the volume units in. If you need to, you're going to have to do a conversion by following the procedure that we learned for conversions. From there, find the volume. It's very likely it's going to be compound volume. We're going to have to add volumes together, or displaced volume, where you have hollow objects. We're going to have to subtract the volumes. Once you have your volume, you do unit analysis. There's an example of unit analysis here. And then just understand if they give you the volume, or they give you circumference, then you're going to substitute that value into the left-hand side, and you're going to do some algebra. So I asked you to do, I believe, 8, 9, and 10 for homework. I'm going to go over, let's go over 10. I like 10. Then we're going to do a couple more, and then you're going to practice. All right, this lesson definitely requires practicing. They're long questions, but if they're practice, it's really not that bad. So let me get my pen ready. My calculator's ready. I'm good to go. Let's go purple. I like purple. Teresa has a rectangular pool, 30 feet long, 15 feet wide, and 4 feet deep. Teresa fills her pool using city water at a rate of 3, so let's just underline that. Feet, that looks good. 395 per 100 gallons of water. Nancy has a circular pool, so let's just stick with Teresa. If I scan down to the end, it's asking who paid more, so I need to find cost. So I need to check my units. I see feet. Do I see cubic feet somewhere? Yes. So my units are good in that respect. So let's start by finding for Teresa her volume. Now a little twist here is, it says it's a rectangular pool, but a pool is not a rectangular. It's a three-dimensional object. A rectangle is 2 dimensions. So this rectangular pool is actually a rectangular prism. Now let's read the whole thing just in case there's any other little twists that come up. So Teresa fills her pool using city water, and then Nancy has a circular pool. Well, again, it's not really a circle. If it's a circular top, what it actually is a cylinder with a diameter of 24 feet and a depth of 4 feet. So again, everything's feet, which is good. Nancy fills her pool with a delivery service at a rate of $200 per 6,000 gallons. All right. If Teresa and Nancy both fill their pools 6 inches from the top. So this is the issue that a lot of students have understanding what's going on here. So first of all, the units are bad. This is inches, this is feet. So let's make inches into feet by doing my conversion. Inches goes on bottom. There's 12 inches in 1 foot. I have 6 over 12, which is 0.5 feet. So they're filling their pools 6 inches from the top. So if the pool is 4 feet deep, it's not 4 feet of water, it's 4 feet of water minus 0.5, because it's not filled to the top, it's filled 6 inches from the top. So the height of both of these pools is not going to be 4, it's going to be 3.5. It says they're 4 feet deep, but I'm not filling the water. I'm finding the volume of the water. The water isn't 4 feet high. The water is a half a foot less than that, which would be 3.5. So the rectangle is 30 feet long and 15 feet wide. And Teresa's circular pool has a diameter of 24. So again, even though the height of the pool is 4 feet, because it's filling the water a half a foot from the top, You have to subtract a half. That's a nasty little twist. I don't like that. It caught a lot of students when this was on the Regents. It caught me. I caught myself. But if you didn't read carefully until the end, then you would have found the volume with the fours and it would have been a different answer. So other than that, this question has no twist. The only twist there is that half a foot from the top, the 6 inches from the top. So now I'm going to calculate the volumes. So I have a rectangular prism and a cylinder. If I go to my reference sheet, I think this is all blown up, right? I don't know why that happened. So remember, you're supposed to write in rectangular prism. Area of the base times the height is length times width times height. For general prism, I write in area base times height. And for pyramid, instead of B, it's length times width. Again, B means area of the base. I don't like that they do that. So we fill in those. So my rectangular prism is length times width times height. And then my cylinder is pi r squared height. So V equals length times width times height. V equals pi r squared times the height. 30 times 15 times 3.5 pi 12 squared 3.5. I go to my calculator. Come on, calculator. There you are. 30 times 15 times 3.5 pi 12 squared 3.5. So I got 1575 and 1583 dot dot dot. And again, units are very important for this type of question. We're in cubic feet. Now I'm going to start my unit analysis. So let's hopefully see if we can find some space to do our unit analysis. I'm going to do each one individually. So let's do Teresa first. Let's get a different color. So Teresa is 15, right, T for Teresa, 1575 cubic feet. So now I'm going to look in the problem for cubic feet. Teresa, money, gallons, no cubic feet. There it is. Cubic feet is going to gallons. 1 cubic foot is 7.48 gallons. Cubic feet are gone. Now I'm looking for gallons for Teresa. I'm going from gallons to money. Gallons goes on bottom, money goes on top. 395 for 100 gallons. So I just fill in whatever they give me there. I don't need to find a unit rate. I can just put in whatever they give me. Now I have money. That's what I want. Is there any type of quantity here? No. So I'm going to go to my calculator. I'm going to do the 15. So let's get my fraction. I'm going to do my 1575. 7.48. 395 over 100, and I get 465 dot dot dot. All right, now let's do Nancy. Let's put an N for Nancy. I know we're a little tight on space here, but it is what it is. So she's starting with 1583 dot dot dot. Cubic feet. So again, I start at the bottom here. Cubic feet is going to gallons. 1 cubic foot is 7.48 gallons. Now I have gallons for Nancy. Nancy is paying $200 for 6,000 gallons. So again, gallons is going to money. It's 200 for 6,000. That gives me money. That's what I want. Yes, many of you can say that. Money is what you want. Alpha y equals enter. Again, I'm going to copy and paste that whole 1583. I don't want to round to the very end. Times 7.48 times 200 over 6,000. I get 394 dot dot dot. So it says determine state who paid more. Well, we got $465. We've got $394. Teresa paid more. Teresa is not a good bargain shopper. I'm going to go with Nancy when I need my decisions made, because why would you want to pay $465 if you can pay $394? That's math, my friends. That's math. So, what was the procedure? There was a twist on this one at the beginning. Because they were filled 6 inches from the top, that's half of a foot from the top. So instead of them being 4 feet deep, the shapes created by the water themselves are 3.5 feet deep. Other than that, the units were good. I found the volumes. Once I had the volumes, I did unit analysis for each of them. The red was Teresa, the green was Nancy. Once I did that, I got my answers, and I just answered the question. I think that the beginning, that twist with the 6 inches was kind of nasty. Other than that, I think it's a very straightforward question. So, number 11, the water tower question. This was a 6-point question in the first ever Common Core Geometry Regents. I believe that was June of 2015. It's a fair question. It's got a little outside twist, but not one that's unfair. So let's go through it. It's going to take us a little bit of time, but it's all good. The water tower, let's start with purple again. The water tower in the picture below is modeled by the 2-dimensional figure beside it. The water tower is composed of a hemisphere, so it's telling you the shapes, a cylinder and a cone. Let C be the center of the hemisphere and D be the center of the base of the cone. It's giving me some dimensions, 8.5, 25. It's telling me an angle is 47 degrees. Determine the state to the nearest cubic foot, the volume of the water tower. So let's stop right there. It's asking for the volume of the tower. There are 3 shapes that make up the shape, so I'm going to have to find the volume for each. This is compound volume. Just moving my water glasses out of the way so I have space. This is compound volume. It's 3 different shapes. So we have the cone. We have the hemisphere. And we have the cylinder. I can go to my reference sheet, cone, hemisphere, and cylinder. They're all on there. Cone, 1/3 pi r squared h. Cylinder, pi r squared h. Sphere, so it doesn't tell me hemisphere, but it tells me sphere. If it's half of a sphere, I just put a half in front of that formula. So my cone is V equals 1/3 pi r squared h. My hemisphere, again, since it's half of the sphere, I put half in front of the formula. And my cylinder is pi r squared h. I'm going to start with the cylinder. The radius, well, if the radius of this, if this radius is 8.5, then this radius is 8.5. So for all my situations with this one with radius, it's 8.5. The height of the cylinder is 25. Hemisphere, v equals 1/2, 4/3 pi. Again, the radius is 8.5. Now the cone, there's a twist because I don't have the height of the cone. So what I'm going to do is I'm going to kind of blow this up over here. And two-dimensionally, I see a right triangle. I want the height because that's the height of the cone. It's giving me that this is 47 degrees. And again, if the radius is 8.5, then this radius is 8.5. This is 8.5. So this pulls from another unit, but a very, very important unit, a very, very important topic that you should definitely be expecting to see. I see a right triangle, an angle's involved, SOHCAHTOA. So we're going to have to do SOHCAHTOA. H, the angle connects the H to the A. That's my O. So I'm just kind of doing this off to the side here. A and O are involved. So it's going to be tangent. Tan of theta equals O over A. Tan of 47 equals X over 8.5. Go to my calculator. Let's make sure I'm in the right mode. I'm in degree mode, which is good. I'm going to type in tan of 47. 1.0723 dot 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 equals X over 8.5. Cross multiply. X equals 1.0723 times 8.5. And I get 9 dot dot dot. So that's the height of the cone. So now I can do 1/3 pi 8.5 squared times 9 dot dot dot. Sorry, I know I got a little messy, but you know, kind of hard to maneuver what I have here. So let's type everything into the calculator now. Let's start with the cone. 1/3 pi 8.5 squared times that 689 dot dot dot. Now the hemisphere, alpha y equals enter, 1/2 4/3 pi 8.5 cubed, 1286 dot dot dot. And the cylinder, pi 8.5 squared times the height is 25, and I get 5674 dot dot dot. So if I want the volume of the entire water tower, well, that water tower is made up of all those shapes on top of each other. So I'm going to add the three of them together. I go to my calculator. I'm just going to copy and paste all three together. So that one plus that one plus the third shape. It is telling me to round to the nearest cubic foot for this question. So I know, you know how I don't say to round to the very end? Well, you round once they ask you a question. It's asking me at this point for the volume to the nearest cubic foot. So that would be 7650. That's the answer to the first question. Again, what did I do to find the volume of the water tower? I found the volume of each individual shape, and I added them together The little twist was I had to use SOHCAHTOA to find the height of the cone. All right, there's more to the question. Let's go blue. The water tower was constructed to hold a maximum of 400,000 pounds of water. I see weight now. I'm guessing I'm going to do what I always do at this point, which is unit analysis. So I have cubic feet. I'm looking for cubic feet. 400,000 pounds. Pounds per cubic foot. There we go. So I'm going from cubic feet to pounds. 62.4 pounds is 1 cubic foot. Now I have pounds. Well, that's what I want. It wants to know if it is 400,000 pounds or more. Is there a quantity or a percent? Yes, there's a percent, so I'm multiplying by 0.85. Now this 400,000, this isn't a piece of information. This is just saying, well, it holds 400,000. How much is this thing going to weigh? You're not doing anything with the 400,000. You're just going to find how much the water weighs, and then from there, you're going to compare it to that 400,000. So let's pull my calculator back up. Again, in this case, I'm using the 7650 since I rounded it in the first part of the question. Since there's nothing on the bottom, I'm not going to type in the fraction. You can if you want. 7650, 62.4.85 gives me 405,756. And my unit is pounds. So, the tower was constructed to hold a maximum of 400,000 pounds. Based on this scenario, my water is going to weigh 405,756. Will it exceed the weight limit? Yes. So can the water be filled and not exceed the weight limit? No. 405,756 is more than 400,000. So is it a long question? Yes. Was it a difficult question? Not really. You had this little twist of SOHCAHTOA to find the height of the cone. Other than that, you found your compound volume, you found your 3 volumes, you added them together. From there, you did unit analysis, and that's a 6-point question. I think it's really fair if you practice this type of question and learn the procedure. These questions take a long time. I'm not going to go through all of them. I'm going to go through, let's do 13. 12 is pretty straightforward. I'm going to go through 13, and that's what I'm going to do. I think this was one of the easiest modeling volume 6-point questions they've asked. It's very straightforward. So you know what? I'm going to kind of have you do this one partially on your own. So let's take a look here. A snow cone consists of a paper cone completely filled with shaved ice and topped off with a hemisphere of shaved ice. So it's telling you the shapes. It's a cone with a hemisphere on top. It's telling me the dimensions, which are already in the picture, centimeters, centimeters. Do I want centimeters? If I glance down, yes. So my units are good. So follow my procedure. The first step is to find the volume. So there's a cone, and there's a hemisphere. Go to your reference sheet. Cone and sphere are both there. Sorry, I got a little messy. Cone and sphere are both here. Cone and sphere. So we've got V equals 1/3 pi r squared h. And we've got V equals 1/2 4/3 pi r cubed. You do it. I'm going to give you a 2-minute head start, and I want you to calculate those volumes. Again, right now you're doing the calculation for the volume. Don't forget, for the radius, you have to cut the diameter in half. I got 183 for the cone, 149 for the hemisphere. Again, it's 183 dot 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 and 149 dot dot dot. The amount of shaved ice, the volume, is the cone with the hemisphere on top. So I'm going to add the 183 and the 149. I'm going to copy and paste what I have in here. And I got 333 dot dot dot. And my unit is cubic centimeters. So it never asked me for the volume, but I know my procedure to find cost or mass or weight or whatever is to start by finding the volume. So now that I have the 333, the volume, I begin unit analysis. I'm looking for cubic centimeters. Here it is. I'm going from cubic centimeters to grams. 0.697 grams is 1 cubic centimeter. Now I have grams. Now I'm looking for grams. I don't see grams, I see kilograms. So I have to go from grams to kilograms. That's a conversion you're expected to know. This is where a lot of students get confused. If it's the wrong metric unit, you just need to do that conversion of metric units. There's 1,000 grams in 1 kilogram. Now that I have kilograms, I'm going from kilograms to money. It's 383 for 1 kilogram. Now I have money. That's what I wanted. I wanted cost. Is there a quantity or a percent? Yes. There's a quantity of 50 snow cones. And now I just put it all into the calculator and I'll have my answer. With money, you're always expected to round to the nearest cent if it doesn't specify otherwise. It does not specify otherwise. So once I get my answer, I'm going to round to the nearest hundredth, the nearest cent. My top, I have 333 and change, 0.697, 1. You don't have to write the 1, but I will. 3.83, 50. And my bottom is 1,000. to the nearest cent, that is 44.53. That's it. So I think as far as 6-point questions go, that one was really pretty simple. You had to find compound volume on top. Once you found compound volume, we just did our unit analysis. There was really no twists there. It was a straightforward question, and that's it. So for classwork slash homework, you're going to finish modeling volume. So this is your classwork slash homework for Thursday and Friday. All right, so I'm giving you 2 days to do this. Is to finish modeling volume. By the way, the key is on the website, so you can access the key. Actually, is the key on the website? I had a little issue being how I can't go to school with the keys. I have my old key for this on the website, so some questions are on there, some aren't, but you can utilize what's on there. And I'm going to post a quiz for you. I'm going to have the quiz due on Sunday night. My suggestion, whenever you find a little bit of time, Thursday or Friday, to sit down and work on this, I would just get the quiz done then. All right, we have plenty of time. I'm trying to be very flexible with the time. We spent the entire week on this one, lesson, even though it is a long lesson, but we spent the entire week on it. But it is important, and if you ever do take the Regents, you're going to see a 4-point question on this, in addition to other volume stuff, which it incorporates. So again, your procedure for finding cost, mass, whatever, you're going to start by making sure your units are good, convert if necessary, to make sure that all the units are the same, and it's the unit that the question is asking for. Once all the units are good, you're going to find the volume. Once you have, if it's compound volume, you're going to add them together. If it's a shape on top of a shape. If it's displaced volume, something hollow, you're going to subtract them. Once you have the volume, you begin unit analysis, and that's it. Again, if it's a problem where it gives you volume, you're going to have to substitute in and use algebra to solve for whatever variable that you need. Again, it's a long lesson. It's something that needs practice, and hopefully that's what you're going to do with it. And that's all I got for you. Enjoy your day. Ask me any questions that you have on your mind, and stay safe.